Today you will learn two new triangle theorems by applying them to calculation and proof-based problems. First, we take a look at the drill, which hopefully you've completed at this point. If not, go ahead and push pause and give them a try. Once you believe you have an answer or you get stuck, go ahead and push play to check your progress. The exterior angle to the vertex angle of an isosceles triangle has a measure of 45 degrees. What is the measure of one base angle of the triangle? In order to answer this question, we need to understand a couple parts of an isosceles triangle. We remember by definition that an isosceles triangle has at least two sides congruent. The vertex angle is the angle that connects those two sides. The other two angles are called base angles. So you have a base angle here and a base angle here. So in question number 1, as we're talking about an exterior angle to the vertex angle, that tells me these sides are congruent and this angle is 45 degrees. And I want to know the measure of one base angle of the triangle. Well, these angles, there's something special about them. And if you don't already know, we will see a little bit later, they both are the same. So we'll set them equal to x, each of them. And you might remember from last chapter, the exterior angle of a triangle equals the sum of the two opposite interior angles. So x plus x equals 45 degrees. When you add, you have 2x equal to 45 degrees. Divide both sides by 2, and x equals 22.5 degrees. That is the measure of one base angle. Now there is some new material involved in this question, so if you weren't able to get the answer, that's totally okay. But hopefully you were able to at least get a picture drawn and recall some of that information from last chapter as you were preparing to answer the question. In number 2, in triangle CAT, an exterior angle to C has a measure of 110 degrees. So let's draw our triangle CAT. The exterior angle to C is 110 degrees. An exterior angle to A has 132 degrees. What side of the triangle is the longest? This particular question, we need to find the inside angles, and that is old information. We know that an exterior angle makes a linear pair with the interior angle, and so we subtract 180 degrees minus 110 degrees gives us measure of angle C to be 70 degrees. 180 minus 132 gives us the measure of angle A. which is 48 degrees. And so we need to find the measure of angle T. And remember, the triangle sum theorem from last chapter says that angle T plus 70 plus 48 equals 180 degrees. 70 and 48 is 118. Subtract 118 from both sides of the equation, which is 62 degrees, equals the measure of angle T. At this point, you'll probably guess which side of the triangle is the longest. In a moment, you'll find out a new theorem which will tell you for sure which triangle is which side of the triangle is the longest. And if you had guessed side AT, you would have been correct. Let's go ahead and take a look at the new material today. Check out these new theorems so that we can continue. Isosceles triangle base angle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So here I have the two sides of the triangle being congruent, meaning that I have an isosceles triangle. It tells us that the angles opposite those sides, or the base angles, are congruent. Now the converse of the isosceles triangle base angle theorem says the opposite. We basically switch the if and the then statement whenever we have a converse. So now we say if two angles are congruent, then the sides are congruent. So it's kind of the exact opposite, or going backwards. If I know angles, then sides, that's the converse. If I know sides, then angles, I start with an isosceles triangle, so that's the isosceles triangle base angle theorem. We will refer to that as the base angle theorem. The next triangle that I have over here is a scalene triangle. In a scalene triangle, if two sides of that triangle are not congruent, so all of the sides are not congruent in a scalene triangle, but this could also work in an isosceles triangle to figure out which angles are larger or smaller and the sides the same. So if two sides of a triangle are not congruent, then the angles opposite them are not congruent, and the largest angle is opposite the longest side. So if this is the largest angle, this is the longest side. And if this is the smallest angle, then this is the smallest side. And this would be the medium side and the medium angle. If we come back up and look at the second example in our drill, or second drill question, the smallest side is the side opposite the smallest angle. The smallest angle is 48 degrees, so the smallest side would be side TC. We'll take a look at how some of these theorems are used in a proof. So this example here, given the measure of segment AB equals the measure of segment AC in triangle ABC. So we write that in our conclusions. AB equals AC in triangle ABC. Remember, we copied the given exactly as is, and the reason or justification here is that it was given. Then we put that information on the picture, that AB equals AC, and we'll move on from there. Our objective is to prove the measure of angle 3 equals the measure of angle 4. Well, because the sides here are congruent, I know that angle 1 and angle 2 are congruent, so measure angle 1, and we'll say equals, since everything here has been equals the measure of angle 2, and the reason is the base angle theorem, or the isosceles triangle base angle theorem. We can abbreviate that as BAT. As I look at the picture, what else do I know? Well, I know that angle 1 is congruent to angle 3. Angle 1 equals the measure of angle 3. And I look at 2 and 4, they are also congruent for the same reason. Measure of angle 2 equals the measure of angle 4. And the reason is the vertical angle theorem, which we already have been abbreviating as VAT. At this point, I've shown that all of the angles are congruent, and therefore 3 is congruent to 4, which is what I was trying to prove going through angles 1 and 2. And since we're going through those other equal angles or congruent angles, we can say that the measure of angle 3 equals the measure of angle 4, and the reason, the transitive property of equality, since this is dealing with equal signs. So we've looked at using the drill questions, a couple examples with the new material, the new theorems, as well as using old information from last chapter. We've also looked at an example of a proof using new theorems and old information from previous chapters as well. Again, that will continue to build our geometry vocabulary to be able to work through additional problems this year and additional proofs. What I'd like you to do at this point is go ahead and try the level practice, which will include questions of increasing difficulty that are similar to the drill questions, where you'll be applying the new information, the new theorems today. And I'd like you to try, I believe, 3 or 4 proofs. These proofs I've helped you by giving you a bank of justifications and or conclusions, really trying to kind of help scaffold you into being able to solve the proofs on your own. So take some time individually or with a partner trying to work through those problems at this time.